Okay, I think we can get started. We have the quorum. Good evening again. I'm Amir Charania, founder and organizer of Dallas AI. I'll be your host tonight, along with Babar Bhatti, my co-organizer and co-host. Tonight we have a wonderful speaker, Lori Glover, managing director of the Global Strategic Alliances at MIT Computer Science and AI Lab, also known as MIT CSAIL, the largest research lab at MIT. Lori leads collaboration between MIT CSAIL and the broader industry, a super exciting role where she connects industry with technologies, research, students, professional programs, and startup ecosystem at MIT CSAIL. She is also the executive director of large-scale research initiatives like machine learning applications at CSAIL, systems that learn at CSAIL, and fintech at CSAIL. In addition, Lori sits on the board of directors at the American Society of Engineering Education, the advisory board of APCO, and Massachusetts Cyber Education and Training Consortium. Lori holds JD in law and has practiced as a member of Massachusetts as well as Florida bar associations. Like you all, I'm super excited to hear from Lori. But before I give the podium to her, or rather the screen in this case, let's have a quick overview of Dallas AI for the benefit of our new members. Our original goal, we are a nonprofit forum to accelerate learning and adoption of AI among the local Dallas community. We still have the same goal, except with COVID and everything being online, we are now reaching beyond Dallas. We are relatively a young group, just crossed our 3-year anniversary, but we have grown tremendously. We are now the largest independent AI forum in North Texas with over 3,000 members, ranging from the senior-most tech leaders to AI professionals to fresh or soon to graduate students from local universities. We have had many exciting events, mainly talks and workshops, partnering with the top local companies and academia active in AI space. And of course, tonight, we are very happy to also include MIT CSAIL in this crowd. If you have any questions, feedback, or like to help us find future speakers, please feel free to reach out to Babar or myself. We are always looking for senior tech leaders, heads of research entities, and authors of books in AI space. For tonight, if you have any question for the host or the speaker, please put those in the Q&A window. Babar will be happy to take any questions for the speaker and ask them on your behalf to Lori. Of course, for networking, feel free to continue using Zoom chat. You can introduce yourself to all participants or network with somebody one-on-one. So without further ado, please join me in welcoming Lori Glover. Lori, all yours.
Thank you, Amir. Hello, everyone. I'm going to share my screen. And okay, well, I'm going to have to go back. Hold on a second. I'm sorry. I had gone ahead when I shouldn't have. Let me just fix that for 1 second. And okay, so right back to the beginning. Now I'll share my screen. So I was just reading an article that Dallas Fort Worth is now outranked Silicon Valley for the high tech startup. So congratulations, that's great.
Thank you.
Okay, so now it's still not working. I'm sorry. Hold on one second. I'm just going to get into presentation. I'm so sorry. I had all this all set up and I messed it up.
No worries.
And there we go. Can you see my screen?
Not yet.
Not yet. Hold on one second then. This is crazy. There we go. Share. I should be able to see everything. Yes, I hope.
Yes, you can see it now. Not in presentation mode though. Yes,
Yeah.
now it's in presentation mode. Thank you, Lauren.
Sorry, I was playing around with this way too much.
No,
Thank you.
no worries.
Thank you so much for the introduction, and it's great to be able to talk to everyone tonight. CSAIL is the Computer Science Artificial Intelligence Lab at MIT, and it's an amazing place to work, and it is a very, very fun job. I get to see technology being created that is, years away, obviously, from being in the commercial realm, and help connect companies with that new technology. We talk about, driverless cars. Driverless cars, everybody talks about that now. Well, we've had them in the lab for almost 15 years. And it's interesting, one of the researcher's children, he said recently, oh, do you want to come and see this new car that I'm working on? The child, the 15-year-old, is like, you've seen one, you've seen them all. I don't need to see another one. So it's just pretty interesting that, that's kind of the way that they think about it. But anyway, so today, this is kind of the overview that I was going to give for the talk. Just a little bit of familiarity with CSAIL. We are, I always say, the quiet guys at the lab. Really, really hard tech we work on, but a lot of times people don't realize the things that CSAIL has actually brought to the world. So I'll give a little bit of an overview of CSAIL and what it is and what we've done. Talk a little bit about the AI timeline. It's always interesting, really, to see where we are in that timeline and why we are where we are now. Of course, share some of CSAIL's latest research and applications. Talk a little bit about our latest initiative on machine learning applications and share some of the challenges that we're tackling in that space. And then also discuss the possibilities and challenges with future developments in AI, kind of give you a little peek over the horizon of things we're working on and things you might be able to see. So, CSAIL at MIT. As Amir had mentioned, we are the largest lab. Our mission is to improve the way people live, work, play, and learn through computing. We look at ourselves as really kind of inventing the future of computing and pushing the envelope on what more can be done, what else can we do. It's a really exciting place. CSAIL was formed back in 2003. It was actually formed when two of the powerhouse labs that really date back to the 1950s came together, the Lab for Computer Science and the Artificial Intelligence Lab. And when they came together, we have CSAIL. We are located on campus in the Stata Center, which is my background behind me and also on the screen. And it is an amazing building. When you do have an opportunity to come to campus, I would love to be able to show you around. It's an incredible place with very active lab space and demos. And it is not crazy to see many robots going around the floors and the halls, and drones flying in the underground parking garage, because it's where we do a lot of our testing. So it's a really exciting place. We do the cutting edge research, pioneering faculty, and really game-changing startups. So we are the largest lab in that we have over 1,200 members. We're very large. We have 125 principal investigators, and each one of them runs a group of anywhere from 4 to 40 people. And that includes students as well as research scientists and postdocs. We are a graduate lab, so most of our students are PhD students. We have a few masters of engineering and some undergraduates now that we're part of a college. We have over 900 active projects, and I'll say a little bit more about that later, because that's a really huge volume. But when you're talking about several hundred students and everyone has to have something new, this is a really vibrant environment where there's constantly new ideas. Sorry about that. So we represent all aspects of computer science and artificial intelligence. In my next slide, I'll show you a little bit more about what I mean by that. But at MIT, researchers have their teaching appointments in departments, but research appointments in labs. So at CSAIL, we represent all 5 schools at MIT and 11 different departments. We have people obviously from EECS and Aeroastro and business school, media studies, brain and cognitive, chemistry, biology, everything. And the really interesting thing is in CSAIL, they all come together, and that's where those intersections of disciplines, and that's where a lot of really exciting stuff is happening. We also have an incredibly decorated group of faculty members. I think we are the only lab in the world that has 9 Turing Award winners. And we do have the Knight Order of the British Empire, the Knight Commander. And usually when I show this slide to people, I look around the room and say, does anyone know who that might be? But since I can't see you or your reaction, I'll just tell you that it's Tim Berners-Lee who invented the World Wide Web. So this is kind of the cloud slide, I call it, for our principal investigators. I like this slide because it is clouds, and they tend to be like soft. They're not hard silos, and that's really the way we operate at CSAIL. But as you can see from this, the spectrum, vision and graphics, robotics, machine learning, artificial intelligence, human-computer interaction, wireless network systems, computational biology, cybersecurity, it's all here. So we really do span everything. The examples that I pulled out, which I'll show you later on, I have some video and some just text, I'll just speak to it. We do, obviously, it's computation, so not everything we do shows really well, but where I could pull a really cool video or a demo, I definitely did. So talking about CSAIL's early contributions, I do like to show this slide for a couple of reasons. It goes back to the 1940s, digital computer and all, but it says a number of different things that CSAIL really has brought to the world. First video game, first email, the password. Professor Corbato just passed away last summer. So we really have brought a lot to the world. But one of the ones I like to illustrate is this fabulous, famous fax machine. Because back in 1959, there was a student at the AI lab who was talking to another student on the phone across campus, trying to explain a really complex design for a new camera, and was really frustrated that he couldn't get his design, like have the other student understand what he was talking about. He's like, I wish I could just draw a picture and send it to you. Well, it was that motivation that actually created the fax machine, and he built the first working prototype of a fax machine to send the image over the phone lines back in 1959. So if you are as old as me, you remember that fax machines didn't actually come into commercial use really until the 80s. And I use that for a couple of reasons, saying that it took over 20 years to actually go from proof of concept and just the understanding and actually having the technology that actually did it to actually bringing it out into the commercial market and having it be adopted widespread. We have also very many startups. So in the side that's bearing here on the left, these are companies that have come out of CSAIL that are still strong companies, and the ones on the right, like Vertica and Silk Arts and some of the other ones, are companies that also came out of CSAIL, but they were acquired by the larger companies. And I bring all of this together again to talk about those 900 active projects, because we are a research lab. Our mission is to have a positive impact through computing, but we really need to collaborate with industry to understand what those most pressing challenges are. And we have it all at the lab. So thinking back my just previous couple of slides, we absolutely have fundamental research that is years away from actually having a commercial impact. We also have applied. We have a lot of applied research where you can take the technology and actually use it right away, and then commercialize tech. We have over 500 startups that we even know of. So we really have the whole spectrum in the lab. And we apply to all of these different industries using our technology. So just a really brief history on AI, which I always think is interesting, because really it's been the last few years that we talk about artificial intelligence, and it seems to be everywhere, and it seems to be the answer to everything. But well, why now? So when you think about it, it was actually almost 100 years ago. Vannevar Bush at MIT published that seminal paper on the differential analyzer, which was just the idea of a kind of a thinking machine. In 1950, you have Alan Turing, who proposed to teach a computer. In 55, you have John McCarthy, who really came out with the AI machine computation. and 55. But here's the one I love, is at 59, 1959, like 60 years ago. You have John McCarthy and Marvin Minsky, who founded the Artificial Intelligence Project at MIT. It's that project that became the AI Lab, which is the predecessor of CSAIL. And you think about how long ago that was. And now really AI is finally coming into the promise that they had envisioned way back then. In the 60s and 70s, it was very basic. The 80s, of course, you have the expert systems. And then now we have the age of AI. But why now? We have vastly increased processing power, inexpensive storage, cloud services, and huge amounts of data. You put all of this together, we finally have the ability to have some of the AI systems that were thought of as really science fiction back in the day when this all came about. So, and I know many of you probably already understand this completely, but just for a refresher, AI is the largest kind of, what we all talk about this, refer to AI, but it also encompasses machine learning and deep learning. So AI is the ability of the computer system to simulate intelligent behavior. Machine learning is a smaller subset on computation, being able to carry out tasks without being explicitly told to do so. And of course, deep learning is where you talk about the neural nets that process large amounts of data. And that's why we're able to do like NLP processing and things like that now. And of course, image recognition. So we talk about AI as kind of a general term. I think most people, when they talk about it, they're really thinking about machine learning. But though all machine learning is AI, not all AI is machine learning. And in the lab, we really try and think about it in kind of two blocks. AI in motion, which you've got autonomous vehicles and robotics, and you've got AI at rest. We talk about your advanced analytics, your NLP and speech, and computer vision analysis. So with that, I will kind of introduce some of the CSAIL projects and industry applications. When I talked with Amir about this, I said, okay, some of the industries that might be interesting are consumer manufacturing, healthcare, airline, telecom, FinServ. So I took your word for that, and I went through and picked out some things that might be applicable there. So in the consumer space, of course, privacy and personalized experiences. In the AI space, I do have some videos that I'll play, but I'll give you a little bit of background. One of the most important things when COVID hit was privacy, data privacy, and how are we going to help people trace things? So what are people as consumers willing to do as an individual? So we use this. And hopefully it's playing. Play.
When a patient is diagnosed with an infectious disease like COVID-19, an important step in slowing the transmission of the disease is contact tracing. Contact tracing seeks to identify the people who have had close contact with the infected individual and who therefore may be infected themselves. This targeted strategy reduces the need for stay-at-home periods. However, manual contact tracing is subject to a person's ability to recall everyone they have come in contact with over a 2-week period. There is need for an automated, privacy-preserving contact tracing system. MIT is developing one such system. Cell phones are constantly advertising their presence using Bluetooth. These advertisements, which we call chirps, can be anonymous and contain no location data or personally identifiable information. Every phone stores a list of all the chirps that it has sent and all the chirps it has overheard from nearby phones within arm's reach. The MIT system utilizes these lists to enable contact tracing for people diagnosed with COVID-19. This system not only identifies contacts, it also estimates the distance between individuals, as well as the amount of time they spent in close proximity to each other. When a person is diagnosed with COVID-19, public health professionals would coordinate with the patient to upload the list of chirps sent out by their phone to a public database. Meanwhile, people who have not been diagnosed can have their phones do a daily scan of the public database to see if their phones have overheard any of the chirps used by people later diagnosed with COVID-19. This indicates that they were in close, prolonged contact with that anonymous individual. Depending on the circumstances of contact, They may be referred to the public health authorities, who may recommend varying courses of action, including symptom watch, testing, and self-quarantine.
So that is something that the researchers actually worked with Google and Apple on. It is a platform agnostic, and it can be used for anything. And it's using a cryptographic technique that generates these randomly rotating numbers that can't be traced back to any individual. And the chirps that are made, the algorithms actually sort in terms of what's medically significant. So how long it was, were you closer than 6 feet to that other chirp? Was it more than 10 minutes in contact time? And it sorts just those things. So you kind of filter out all that noise and you have only the real medically significant data that completely preserves privacy. So this is something that, you know, early on in when the world was dealing with COVID, you know, some of the other countries introduced really intense contact tracing, but in the US, we're very, very concerned about privacy. So this is something that we worked with you know, Google and Apple on to be able to do it in a privacy preserving manner. So again, from a consumer standpoint, things that we're working on are, you know, personalized advanced data analytics. And there's so many different ways where you can get down into that. There are tons of data systems and structures there. One of our projects had been MapD, and it's actually a startup now. But it was a really interesting idea of, you know, building a data management system on a GPU. But the way it worked was you actually could take like every tweet and, you know, from your brand. Like if your brand was, I don't know, I have a Solo cup next to me. So, you know, it's Solo and you want to see what people are saying about it. You can track, you know, the brand about it. You could track every word that was said. They did an example of every word uttered in Congress in the last, you know, 15 years. And then you could kind of build and understand patterns through it. Even donations that were made to a political candidate and going right down to the actual space on a map of the country, where it was and what it was, how much it was. So there's just really interesting use of data to be able to visualize it, but get really interesting trends and understanding out of it. And one of the ways that, you know, a lot of companies looked at it were really of kind of on that branding and understanding of what people were saying about their brand. So it's an interesting, interesting company now. Also, we have this fascinating EQ radio. Now, EQ radio itself is probably about 2 years old, but it's had a lot of advancements, but it has a cool video. So I'll show the video and then we'll talk more about it.
This video describes EQ radio, a new technology from Professor Katabi's group at MIT that can recognize people's emotions using wireless signals. Was there a moment in your life when you looked at someone's face, but you could not figure out how they feel? What if your wireless router can tell people's emotions even if they don't show them on their faces? This is exactly what our technology does. This is our device. The device transmits a wireless signal which reflects off a person's body and comes back. It captures these reflections and analyzes them to infer the person's emotions. Specifically, our algorithms zoom in on the wireless reflections to extract the minute variations due to breathing and heartbeats. We then further analyze these reflections to extract the breathing signal and the heartbeat signal. We then zoom in more on these signals to obtain individual heartbeats and breathing cycles and feed these as features into a machine learning algorithm to recognize a person's emotions. The device can automatically know if the person is excited, angry, sad, or happy. Our device can recognize emotions with an accuracy of 87% while relying purely on wireless signals. We envision that EQ radio can be used in many applications. It can recognize a person's emotions while he is watching a movie and provide movie makers with better tools to evaluate user experience. It can also allow smart environments to detect emotional states like depression and inform us to improve our emotional well-being. It can even enable these environments to react to our moods and adjust lighting or music accordingly. To learn more about this research, please check out our website.
So that's an interesting one on EQ radio. It has, any project in the lab doesn't just stop when they've completed one find. It's a constant trajectory, and tying it in with the smart lighting, smart heating, all of those different things is definitely something that this group is worked on. And in a little while, I'll show you another spin out company, Emerald. It's built on a technology that monitors. Mostly it was really built to monitor elderly folks staying at home. But one of the things that it did incorporate into it was from this EQ radio on the depression, because the algorithm can understand if someone isn't moving around as much as they used to do, or if they're spending, kind of too much time in front of the computer. So, it will help understand a person's behavior. And I'll talk more about that later. But I don't know how many of you, because I can't see anybody, is a big fan of the Big Bang Theory, but you may have remembered EQ radio on the Big Bang Theory when Sheldon is walking around with a box, and he looks and he goes, "Penny, you're smiling, but it says you're angry. I don't understand." So they were making fun of us, but EQ radio had the big time with the Big Bang Theory. But it is a really interesting research vein, and they're doing amazing things with wireless signals. And it definitely does affect the consumer in terms of their whole, the way they interact with their environment. So next, we'll talk a little bit about manufacturing. So mainly in warehousing and robotics. We do a lot with robotics. We have every kind of robot at MIT, at CSAIL. We have robots that are, 6'5", 350-pound humanoids that drive cars, climb ladders, use power tools. They were Atlas from the DARPA Robotics Challenge back at the time when there was the earthquake in Japan at Fukushima, and the reactor 4, no human has ever been in it. And they realized that we couldn't really assess it because the robots we had at the time couldn't move all the debris. So this humanoid robot actually can do all those things. And it's a pretty amazing robot. We had for a while, oh my gosh, I'm blanking on his name. The robot that's going to build the HABs in Mars from NASA. So we worked with that robot for a while. Can't believe I'm blanking on his name. Sorry, but that one. And then we have, every kind of robot that goes on the floor, walks, flies, you name it. We even have tiny, tiny origami robots that are smaller than my fingernail. They fold up on each other. They can change shapes inside their shapes into all little things. But the one that is the most promising right now that's in testing is one that is actually made of sausage casing. And it folds up into a tiny little pill shape, and it can be ingested and controlled by an external magnetic field. And it can inject drugs, or it can perform surgery in the stomach, like removing button batteries is the example that we used in the research mode, and then just be eliminated through the digestive system. So it eliminates the need for any kind of surgery. We're piercing the skin. It can be done by a tiny, tiny robot. Pretty amazing things. But in terms of manufacturing, we have this robot here, which is a Ava robot base. And Daniela Roos's group has taken this base and put on it a UV light system that is calibrated perfectly to kill COVID-19. And it is programmed to be able to sanitize the whole warehouse area, and it knows, to not to put the UV lights on a human. It can stop, and it's right now being used at the food bank and a few other places. But I'll play this video for you. that just gives you an example of that disinfecting robot, and it can disinfect 4,000 square feet in 30 minutes. It's pretty incredible. After the original robot, the original one, it's piloted by a human and it maps it all out. But then after that, it just goes autonomously. And it's a pretty incredible thing. It's being looked at to use in a lot of high-rise office buildings, like to disinfect bathrooms between people. There's lots of different potential uses we're discussing for it. So it's a pretty interesting way. I mean, we're going to be dealing with COVID and other issues for a while now. So I think it's a great contribution and a great application of some cool technology. So also in Daniela's lab and several others work with soft robotics, which are unique in being able obviously to grab things and sensors. We have robots that in the soft robotics, they have sensors in the material itself. So it's basically giving the robot hand the ability to feel and tell the difference when it picks up a metal can versus a paper cup versus a plastic bottle versus a glass bottle. And that's great from a lot of different things of having the robot be able to actually function, much like a human. When you see a plastic bottle, you kind of know what it should weigh and how it should feel. And so it can go through tasks just on understanding what the object is when it picks it up. But we actually also have recycling robots that go and sort through tons of recycling, and they can just sort it in the bins just as humans do, because they know what the object is when they touch it. So soft robotics has a lot of possibilities and a lot of really great uses. And here's some of the latest work that we're doing with soft robotics. So that's a little bit on soft robotics, and the whole idea of sensing and having the robot have understanding of what it's dealing with is definitely a line of research that we're working on. The next one is like a robot as a coworker and a partner. We have been doing a lot of work with robots receiving direction, if you will, other than from code. So we've been working with brain signals to teach a robot to sort. So right now it's binary, either they can, with paint and wire. So it kind of operates that, when you're thinking about something and I don't know, I always go to pick up my keys and instead I pick up my phone. I'm like, I shouldn't have done that. And that little bit that your brain goes, it reacts to that. So it's constantly learning about what picks up as paint and what it picks up as wire. And again, it's just binary right now. It's two things, but think of the possibilities of what could be done. Similar along that, in this next example, it is a robot who is a co-worker, in that what they're learning from is muscle signals that come from a patch that is placed on the back of the arm. And it is taught signals like, you pull your hand up twice, it means raise, put your hand down, it means put the material down. But other than that, it works pretty well as a partner in helping people. Here's an example. So here the sensors are on the forearm as well, and they're picking visual signals. Great. So along the lines of manufacturing, they're not really in
Laurie, it's a bit hard to hear you.
It is.
Yes, it was fine a few moments ago, but after the videos, I think something changed. Can you try tweaking your volume?
Okay. Can you hear me better now?
It's slightly better, yes.
Oh, hold on. I got this one. Stop it. Sorry. Is it better?
It's better.
Okay. Sorry about that. I was going to say in manufacturing, though it's not artificial intelligence, it's more, it's some cool stuff that we're doing, and I can share the links. I did put at the very end of my presentation a list of other things you may want to check out, papers and videos and books too, and other things. But Stephanie Mueller from our lab does really amazing things in human-computer interaction. And she's got some work now that she's done with sprayable surfaces. I don't know if anyone's seen this, and I'm hoping I'm loud enough, right?
Yes, you are now. Yeah.
Good, because as I'm going to talk about this part. So in sprayable surfaces, it's actually a conductive ink that is spread on like a copper wiring. And what you can do is basically have it play music, control light switches, do all kinds of things, which is fascinating. But she's also taken this ink in a chromatic ink that can change its designs under a special UV light. And one of the really interesting things we talked about recently is, so we had Halloween and we have all this candy and everything that has, little pumpkins on it. And from a supplier position, obviously with many companies that you have this candy supplier or whoever else would have to buy it all back, and they'd have to change all the packaging, and there's waste and there's all of this. Wouldn't it be great if you could just, have the ink that sprays on and has one design, and then you have it, brought back in the, warehouse, and you run the light over it and it changes to candy canes and nothing else has to happen. So that ink is something that we do. If you want some links on sprayable surfaces and the chromatic ink, I can certainly share with that. And it's actually, she's brought some of this transferring conductive technology to even things like a sofa. And it is sprayed onto the sofa. It knows when a person sits on the sofa. You never have to touch a remote control, and you can actually control your television just by waving your hand over the control portion down the arm of the sofa. So it's some pretty amazing technology, and we do have good videos on it, but it's not really artificial intelligence, but I'm happy to share them because they are some of my favorite recent work. So moving on to the next. We have, oh, I'm so sorry. Hold on a second. I need to stop that. Oops. Stop. Sorry. Moving on to the next is healthcare. We have a lot of people doing work in the healthcare space, and really on everything. We have new drug discovery. We have, patient care. I'm going to talk about some better MRIs and talk about Emerald, in using our machine learning to anticipate heart failure. There's just so much going on in the space. You have a lot of work on breast cancer and, helping patients understand a better path to a treatment that has a better, more like if anyone's heard of Patients Like Me, with all the data about a patient who has a similar diagnosis and similar treatment plan, really what is the best path for someone with your specific needs. And we have a lot of work on that and really helping a personalized medicine. We also have a lot of work in telemedicine and a whole bunch else on, emergency room efficiency and deployment, and a ton there. But I thought, again, some of the cool videos that we have, instead of me just talking, are on some of these really fun projects that we've worked on. Emerald is the first one that I wanted to show you, and it comes out of Dina Katabi's lab. And it is fascinating because the concept of it really started years ago, 7-8 years ago, as just the ability to do really, really accurate indoor geolocation. That's what it was. That's what we do. We solve problems. But as it evolved, we realized we could take breathing signals and heartbeat signals, and a whole bunch of other things could be built into it. The algorithm with Emerald, when it runs, you'll see what I mean, is it can distinguish between 2 or more people in an area. It can distinguish between sitting down, falling down, laying down. It proactively can monitor someone's health. And this is the technology that, when we saw EQ radio earlier, that depression and monitoring some of that mood has been built into. So this is Emerald.
Every year, 2.5 million elderly people are treated in emergency rooms because of falls. 9 out of 10 falls occur at home, and frequently when no one else is around. Fall-related injuries are often a catalyst for a transition to an assisted living facility, which costs on average in the United States $91,000 per year. A new device developed at MIT can help. Introducing Emerald, a modern fall detection device for caregivers and the elderly. Unlike traditional fall pendants, there's no need for the individual to wear any sensor or modify their behavior in any way. Emerald tracks the 3D motion of a person from the radio signals reflected off their body. Emerald works even if the person is in a different room than the device. Emerald sits in the background and alerts you by text, phone, or email if it detects a fall in your parent's home. Emerald is intelligent and can display changes in mobility over time to help predict and prevent falls and identify when quality of life is changing. Emerald, modern fall detection for caregivers.
So that is something that is commercially available now because it is a spin out, and it is being used in many of the nursing assistant facilities in the Cambridge area. And it's a really amazing technology. Again, they've added so much to it that's a little bit older, but some pretty cool things. So Julie Shaw is a roboticist from AeroAstro, and her main area of research is having humans and robots work together. And one of the areas that she is looking at is medical assistance robots. And in this case, I'm going to show you, it's a cute little video of a little neuro robot acting kind of as the charge nurse on the floor and taking into consideration all the amazing amount of detail that a charge nurse usually has to run with. What needs to be done medically, what nursing staff is available to do it, what equipment is necessary, what rooms are open, all of that together. And a big part of this was having a trust, if you will, built between the humans and the robot as they're working together in this scenario.
What is a good decision? Right, like, and it kind of made me like, I don't know.
These are all the things that it's thinking of and pulling into consideration.
What is a good decision?
I recommend placing new patients in triage beds on 5.
What is the bad decision?
A bad decision would be to place a scheduled cesarean section patient in room 14 and have Nurse Kristen take care of her.
I always think for Nurse Kristen.
Ginger, what's a good decision?
I recommend placing a scheduled section patient. Nurse Meredith will take care of her.
I don't know if you plan to go back for one, but for me, I'm like, this is one.
Ginger, what's a bad decision?
We are not going to
Decision would be to place a scheduled cesarean section patient in room and have Nurse Amy take care of her.
I agree.
So it's great to see that the humans accepted the robot's suggestions over 90% of the time. I don't know, every time I see that though, I wonder about Nurse Kristen and Nurse Amy. So, so on the other side of imaging, we actually have a lot of machine learning, artificial intelligence applied in the imaging space, and computer images are just amazing with what we can do. We actually have algorithms now that can fill in kind of blank spaces in an image. It's really, really great in identifying images outside of their normal context. So when you see a fork on a plate, it's pretty easy for the system to understand, the computer vision system to understand that, well, it's a fork and it's a plate because it's in the kitchen. But when you put a fork on a pillow, the system doesn't understand that. So we've got a lot of work on identifying it, no matter what context it's in, and really being able to be accurately identified as that object. In a medical sense, we are using different techniques to be able to get better understanding of images and have the images also be able to understand what a normal image looks like and be able to pull out irregularities and things that would need more attention. So in this case, it happens to be around a placenta, and it happens to be with improving fetal health. Like if there's a challenge during a pregnancy, it's very difficult to be able to do those examinations and see the shape, the detail, the current MRIs or ultrasounds don't show enough detail to be able to understand what's causing problems. But the new treatment like this with this different MRI system actually can give a lot of really good detail and really help physicians understand and even potentially predict with biomarkers as to when there could be a challenge in this case. But here's this one. That's that one. So as you can see, it kind of divided it up, flattened it out, be able to actually look down at the image and be able to really see across the whole image instead of having obstructed views from the shape and the technological limitations. So when we talk about airlines and travel, so this is always an interesting one. And here we go. So safety and security. So we now have a neural network that actually learns when it shouldn't be trusted and will tell you, not here. I mean, don't trust me here. We have many, many breakthroughs in cybersecurity, from obviously better identification of cyber attacks to stopping whole classes of attacks. And I use this example to remind myself. We have the example, I don't know if you've probably seen it. It's a dashboard of a car and it says it's going 130 miles per hour, but it's in park. So obviously that can't be right. The car is hacked, if you will, and how to stop that and prevent some of these challenges in the auto space. So predicting people's driving is something that we're using a lot with the artificial intelligence and AUVs, and interacting with human drivers is one of the great challenges of autonomous driving. One of our faculty, John Leonard, does a lot of work with autonomous vehicles, and he kind of envisions a time when all of the vehicles are autonomous, and thinking, okay, well, as a robot in a car, how would you negotiate a left-hand turn across traffic? Because as humans, we usually look at the other driver and be like, hi, can I please, can we negotiate this? Can you slow down for just a minute and let me go? But how do autonomous vehicles do that? And he wonders, would it be something like, do they negotiate a payment between each other? Like say, hey, I'll give you a nickel if you let me go. How do they come up with a system of negotiating those challenging things? But predicting how people will drive is also helping understand how these cars would actually interact or react, I should say, to a certain situation. So again, this is just a quick little video that talks about social behavior for autonomous vehicles. Where's it not going? Go. I don't know if this is going to go. There it goes. So yeah, autonomous drivers have to understand the intent of human drivers. This is for that in-between time when we're going to have AUVs and human drivers on the road. So how do we predict what a human is going to do? I don't think it's ever possible 100% of the time, but this system at least tries to make some inferences from a way a person would react in a certain situation. And it makes estimates online for human drivers and predicts trajectories. Yeah, this doesn't have any music with it, so. But reduce prediction errors by 25% and better explained autonomous decision-making. And because there's going to be a time where we do envision that there will still be obviously human-operated vehicles on the road, and how do autonomous vehicles negotiate with human vehicles when we can't just, again, say to another autonomous vehicle, hey, I'll give you a nickel to allow me to do that. And these are just other examples of how we're negotiating a merge. So, all right, altruistic and yeah. So anyway, you probably get basically the idea there. Now, this other one here is moving efficient. It's algorithms for moving people and things. And it has received a lot of attention from a number of different companies. When it was published, the whole idea behind it was New York City has 13,000 taxi cabs, and it's crazy and polluting and everything that goes along with it. Well, can you serve the needs of New York City in moving people with ride sharing and rerouting? And basically that's what this algorithm does. It can reroute on the fly. So it's not a pre-programmed route. And it takes 4 people to share a cab. And it can do 98% of all the needs necessary in New York City with this rerouting capability and take care of it with 3,000 taxis instead of 13,000. It can also predict surge times and send, hypothetically, autonomous vehicles to a spot where you would need more taxis to reduce the surge. And it can do a lot of really interesting things. Now, and this doesn't really say anything and it's hard to read, but I'll just play some of it so you can see some of the movement going on. But some of the other applications can be with movement of goods, movement of all types of things. It's a routing algorithm. It's a very efficient routing algorithm in terms of sharing and the ride sharing piece, but also prediction. So it has turned into a new startup, and it was called Routable AI. And they are, again, leveraging this algorithm to do all kinds of routing through like your supply chain and a whole bunch of other stuff. Very, very efficient routing algorithms. So again, this one just kind of talks about the vehicles and how it goes, and you can see the prediction patterns and how things are going, but I'm going to stop that one. So think about it in terms of airline and travel. If you could predict where there were going to be surges, like a need for transportation, you could actually send people or send the cars there to help people out. You could reduce any kind of traffic congestion, which would be really helpful in commuting times. Think about it with airlines, also in routing luggage and all kinds of other things that they have to do. Just really, really efficient in getting things to places, and goods, obviously, too. So that's just another example. And then telecom. So in this case, I didn't really have any great videos, but we do a lot of work with telecom. Obviously, the chatbots, we do a lot of work with improving natural language processing and speech recognition, and understanding it not just with English, but across all different kinds of languages, and being able to have the chatbots understand and respond. And not, we're doing a lot of work now, not just as asking a question like against a database, and what is your problem is A, B, or C, but really having the, I guess, the nuanced understanding behind the language, so that the chatbot realizes contextually what it is that we're talking about. So we're doing a lot more work about having a kind of a more advanced interactive way of speaking with the customer through language processing, but the chatbot really understands more contextually. Of course, understanding and analyzing customer data to improve a customer experience. Predictive maintenance, a lot of work, remote predictive maintenance and improving network reliability. Cybersecurity, again, I mentioned some of that, and that's what this example is here. And projects such as aggregation congestion control to address problems with congestion traffic on the internet and things like that. This example that I have here is a little video, but it's not very much going on, but it kind of just goes through, and it was a project called AI2, and it was an AI-driven predictive cybersecurity platform. It was an interesting way of learning it, and I'll just let it go and I'll talk over it. It's big data machine to defend, okay? And Pattern X is what it has become. It is a new startup, and it uses active learning to detect 85% of cyber attacks, and it reduces false positives. So this is something that has had a lot of really, really positive experience. So the human actually confirms, and it learns in the feedback loop. And yeah, supervised learning model. So anyway, that's the result. And it reduced false positives by a factor of 5. So it's pretty incredible. It won a bunch of competitions. It was some pretty cool work that they did with that. Oop. So in financial services, now we do have a fintech at CSAIL initiative, and that is doing a lot of work in the space. And it really covers everything from your advanced analytics and data sharing and a whole bunch of other stuff. Cybersecurity, chatbots are part of it, but also does things like blockchain and some of the new cryptocurrencies and payment systems and how all of that works. But some of the significant things in FinServ is better risk prediction. So Andrew Lowe is one of the faculty who is a faculty lead for the FinTech initiative. He does a lot of really amazing work with risk prediction and risk in all kinds of things. And I think I used one of the examples here, credit card holder delinquencies and defaults. And he's just done some really incredible work. And I think I put this paper in the link, but if you need anything, you can just reach out to me. I'll send you the information. Scram is the newest one that we're working on right now. And right before this meeting, I had a Scram event. So Scram is secure cyber risk aggregation and measurement. And it is a really, really cool new technology that we've proven works. And we just did the very first project with it. It concluded and just a couple months ago. We just did the paper about a month ago. And the idea is, how can you share data to gain insights? I mean, companies don't want to share their internal data with their competitors, especially like their cyber attack data. Do you really want your competitors to know how you were breached or if you could potentially be breached? They don't really want to share this stuff. But in order to learn from it and to understand it better, we need to share some information. So we needed to develop a framework to overcome the barriers of data sharing. And in this case, we trained machine learning on encrypted data. So it can be shared without actually knowing what it said. It's using fully homomorphic encryption, and it's a really, really cool application. Phase one of the project was with several large financial services companies, and it yielded the benchmarks. As I said here, the benchmarks on the adoption rates of 171 critical security measures, as well as identified links between monetary losses from 49 security incidences and the specific sub-control failures in each instance. So the companies that participated got really, really amazing feedback and understanding of what their data showed, and being able to really address some of their cyber problems. They provided impact into the problematic cyber risk control areas that they really needed to spend some additional time and scrutiny on. This is going to do a phase two. That was what the meeting was about earlier today. And phase two is looking for data partners. It's not a cost. If anyone is interested in participating, please do reach out to me. It's just being able to share the data. And the way it works, I'm often asked, so I put it down here, the average salary question. So think about if we're all in the room together, I don't know, what are there, 43 of us. We're all in the room together and we wanted to know, what is the average salary in the room? Well, not everybody's going to jump up and shout out their salary. So we kind of start at one end of the room and go around in a big circle. And we say, okay, you know what your salary is. Pick some number, any number you want, and add that onto your salary. And then that number, pass on to the next person. And then that person will add some random number onto that number, and goes all the way around the room. And at the end, you have this probably very huge number. Then you just go backwards and you say, okay, I've got this huge number. I'm just going to take off the random number I put on. And he goes backwards around the room. And then you have a number, you divide it by the 43 people in the room, and you have the average salary. It kind of works like that. You don't know who said what, who contributed what. You just know simply that there was data contributed, and that that there was value in that data, and you wanted an answer from it. So it's a really, really interesting way of understanding data. And cyber right now is one of the things we're looking at for, but we're also looking at it in different sectors. Like think of, automotive sector, who has tons of different vendors. And there may be things you want to understand from all of your vendors. But again, your vendors don't necessarily want to share all their data, and you're not going to share your data with the vendors. So how can you do it where you really know that they can't see, no one knows who contributed what, or read the data in any way, but you can actually run really cool queries over it and understand a lot from that data. So that's the basic premise of what Scram is. And it's just a really computationally secure way to share data and guarantee privacy, that no one knows anything. So that's cool. So now I'm just going to talk to you briefly about initiatives. This is what an initiative is. It's like if you're looking at partnering with a research lab, it's all these different ways, but I wanted to call out initiatives because it not from the fact of sponsored research or something that is more fundamental and far away. It's not a startup, but initiatives are ways that companies do work in getting things that are really close to their heart. It's something where there's a challenge, there's no commercial product, the solution on the market, and you really get to say, like, I need a solution for this, and you see how to do it. So that's really what initiatives do. And I talked for just a couple minutes on machine learning applications, and I'm running late here. The premise here is that all industries, they're companies that are awash in data. We have all of this data. Machine learning tools are so useful for so many different things. But for many companies, navigating this landscape is really challenging. In July, 2020 Wired article states that fewer than 10% of companies are actually using AI. And 8.9% use voice, ML, or some kind of AUV. And adoption is heavily skewed towards the largest companies with 24.8% deployment in companies that have over 250 employees. So really, it's not as wide use as you would think with all the challenges. And we try and understand, well, where are some things that using AI and machine learning can really help companies. So along with the power machine learning brings, it also brings automation. And one of the other things I have been involved with at MIT is we started the AI in the Future of Work conference. And we started about 4 years ago because we were hearing some honestly pretty crazy things. So if you work with robots every day, you know that the singularity is not coming anytime soon. But we really wanted to understand, well, how can companies help their workforce address with some of these challenges in automation? So this also will do some of that addressing. I meet with hundreds and hundreds of companies, and no one has ever said to me, I want to get rid of my entire workforce and make it all robots. No, everyone is more concerned about how to be efficient, how to be obviously competitive, how to employ automation in key functions that people can do better, more exciting jobs, less dangerous. And all of those things, yes, but not 100% replacement. Things will change, but it's more tasks than jobs. And right now, very few companies are unsure of how they're going to use machine learning, and the PhD level education is really required to create these models and train them and deploy them. So how do we make this better? So this is our approach. This is what an initiative looks like. Is there's small groups of companies working with the faculty. And this one also has the CLO board, because I think it's really important with machine learning and the workforce. It's kind of comes together. And this I wanted to share because we had the first meeting with the board of the companies, that the founding members, just about a month or so ago. And these are some of the challenges that came up from the board meeting. And can machine learning training be done on encrypted data? So no, sorry. Well, the answer to that is yes, because we have Scram, but they didn't know about it when we had this meeting. So certainly can share that. How do you structure data collections without giving up your data? Enhance computer vision in privacy preserving ways, and how do you make more secure systems? Efficient ways to utilize ML and data lake. Models are expensive in energy power. I'll talk about that later. And meaningful approaches to identity information extraction. Can you do a better approach? Of course, forecasting and predicting, just-in-time inventory coordination, logistics management. How do you bring NLP understanding into practice across languages? I mentioned that earlier. This is a big area of research for us, is all different kinds of languages, including languages with use in smaller user communities. And of course, chatbots. And I alluded to this earlier too, is that we are working on, again, it's not like peeing against a database. It's really having the chatbots understand, see those relationships, or understand in a more contextual manner what the speech means. So these are all things that we're working on. And the outcomes of something like this are new tools. This is, again, ways that we work on timely relevant problems with industry. We create new tools, and we hope that we can positively impact the future of work. But there is still work to be done. So there are lots of possibilities, but there are still challenges with the future developments in AI. So some of these challenges are explainable AI, robust, adversarial, bias-free, ethical, energy efficient, and sustainable. And here are some interesting things that we're doing in the space. So for explainability, many industries need to comply with regulations and explain why an AI system is making the recommendations it is, like the transparency of that black box, particularly in things like financial services. How do you explain to a regulator why it made that decision? We need to be able to explain that better. So in this case, and again, this is just a little video, but we conducted over 100 trials to validate the algorithm using probabilistic risk to really reason and understand a little bit more. And then I'm not going to show because I know I'm running late, but just to understand, like, be able to explain a little bit as to why the decision was made for this algorithm actually made it. In this case, we've got the human drivers negotiate traffic in severe limitations. Okay, so here we go. Probabilistic risk using in AUVs. Understanding, again, explainability of why it makes this decisions that it made. And in this case, we're showing this example. And the risk is assessed in various times. And why is it given a low risk? You can explain it, why we gave it a low risk, why we gave it a high risk. And this is, again, it's not 100% perfect, but why you would make that move, we're taking a clearer step into being able to explain some of the decisions that the system is making. The other challenges that are pretty significant are the robustness and adversarial AI. So building reliable AI systems is really important. If not, it can be really detrimental. And it's really unnerving if an AI system can be manipulated. So we are doing a lot of work in this space, and you probably have all seen this if you're in the AI field. This is from a long time ago in 2013. This is an image classifier, and this is kind of one of the things that we wonder, well, for humans, we look at both of the pictures on the left and the right, and we think it's a dog, right? I don't think anybody out there is going to raise their hand and say, no, it's not a dog, it's a dog. But can you see any differences between them? Again, I can't see you in this case, but usually people are shaking their head going, no, I don't really see anything. Well, there are differences. But the differences are really at the pixel level. So they're these little tiny purple pixels. So there are changes, there actually are. But to the human's eyes, we're like, no, it's a dog. But for the image classifier, it says that's a poodle. Okay, it's a dog. But with the changes now that are made in the middle box, this is now an ostrich. So why? That's something that we really still can't explain. Like, why those few pixels? Why did you change it? Why did it make it look, this classifier, change it from a poodle to an ostrich? That's an interesting and entertaining one. But when you get into computer vision for AUVs, that's when it gets kind of scary. So in this one, again, every human here will probably look at all of these and say, okay, yeah, that's a stop sign. It's a stop sign that has some tape on it, maybe a little graffiti, but it's a stop sign. In this case, though, this graffiti and the stickers caused the neural network to misclassify the stop signs as speed limit 45-mile-per-hour signs, and not just once, in 100% of them. So when you think about what that means, when you think about what that means for autonomous vehicles, like I want to make sure that the car I'm riding in knows that that's a stop sign, and you're not going to fly through a stop sign at 45 miles an hour. This is, again, on fooling image recognition. This is something that we've done in the lab, and we've purposely taken these images, these materials, objects, and manipulated them so that this image classifier recognizes them as something other than they are. So we're purposely playing with the adversarial and trying to understand, I guess, reverse engineer, like, well, how can we make the system better so it won't be fooled? And in this case, again, I think every human will say that that looks like a turtle. But for some reason, the image classifier here is saying, no, it's a rifle. And I'll tell you, it's saying that because of the red markings that were put on this and the flip side of the turtle, which, again, why is it doing that? We're trying to understand. And this is a cool little video. So I'll play this one because it shows in a variety of different scenarios how it misclassifies. It says it's a rifle from every angle. Yes, and that's baseball, but it's espresso. So it's not just the shape or the color, texture. I mean, it's just an object that we've manipulated and are fooling the neural network. But we need to understand why the neural network is making those mistakes, so that when the systems are released in the real world, they are not hackable, or you can trust them to do what they're supposed to do. Sorry. Okay. So now a big challenge, of course, is bias-free and ethical AI. AI systems can be unfair. And there definitely has been the recent study showing racism in facial recognition. And if you train with biased data, you're going to get biased results. And that's basically what it is. And we have developed an algorithm that can automatically debias data by resampling it to be more biased. The algorithm can learn specific tasks like face detection. It can learn underlying structure of the training data. And in this case, this algorithm decreased categorical bias by over 60%. Compared with other state-of-the-art facial recognition models, while simultaneously maintaining overall precision of the systems. So we are really working on helping to create more bias-free systems as well. When we talk about AI and ethics, this is a constant theme across everything. We actually have Randy Davis, who is one of our faculty members, is the ethics advisor in the FinTech initiative, because ethics is so important in so many ways. oftentimes people say, okay, there's an autonomous vehicle and you're a passenger in it, and now it has to make the choice in an accident of, hitting an elderly person or hitting a child. What would you do? What would a human do? And that's often what we say. It's you can't, like, you're going to either hurt the person who's a passenger, or you're going to hurt a child, or you're going to hurt an older person. It's a hard decision for a human, never mind for an artificial intelligence system. So I think it's just very important to always have ethics guide us in how we are deploying these systems, and where they should be deployed and where they shouldn't, and the boundaries of them. So I think ethics really runs through pretty much everything that we do in artificial intelligence, and it's a constant theme. IPRI is the Internet Policy and Research Initiative at MIT, and it's actually housed in CSAIL and led by Danny Weitzner. And it's a really, really interesting center, because if you look at Congress and some of the other ones, I want to say Congress has 2 engineers, I think. So people who are making the laws and people who are making policy don't really understand a lot of the technology. So IPRI really is trying to leverage some of MIT's, I guess, convening ability to bring policymakers, regulators, other people who are making rules around the use of technology and what companies must do in terms of their technology practice, having them have a better understanding of the true capabilities of the technology, and where there are limits and where we're not quite there yet. So it's really important to have these discussions and these opportunities to have the conversations with policymakers. We also have an MIT AI Policy Congress, and again, it talks about ethics and all kinds of things that are affecting AI. Is that AI being applied? Basically, in business, governments, and people have to come together and craft sensible regulations around the use of AI. And it's really important that everyone has a voice in it, as it does become more prevalent in our society. So another big challenge is the high cost of AI. And it's interesting because people seem to like, oh, just write an AI for it, it'll solve all the problems. Well, OpenAI's GPT-3 is the largest language model in the world. It can write fiction, it can translate legalese, and yes, I'm a lawyer, that's a hard one to do, and answer obscure trivia questions, which is all fabulous and great, but it comes at a huge cost, not only monetarily, of $4.6 million, but 355 years in computing time. And it's assuming it was trained on a standard neural network. Think about the times of energy, the cost to the planet really is a big part of it. Researchers at UMass Amherst said that training a large deep learning model created 626,000 pounds of planet warming carbon dioxide. So there are big issues here with the high cost of AI. And this is a paper, and you can link to it here. It's on shrinking deep learning's carbon footprint. We have a lot of people working on that. And then this one, again, I know that I'm pretty much out of time, but this is the idea of actually taking the most salient points to be able to run an effective deep learning algorithm, and but not have it process so much. And so this one is kind of taken from nature, and the idea of it running on 19 neurons. Oops, sorry. These are some of the additional resources I put together for you. Again, they're just links to papers and articles. And I love Julie's new book coming out, What to Expect When You're Expecting Robots. Maybe she will be a speaker for you in the future. It's very cool. So it's just extra things to think about. And with that, I will just say thank you and questions. And Amir, I think I'm pretty good. 2 minutes early.
Thank you, Laurie.
Okay, so I can stop sharing my screen.
Yeah, so Laurie, a bunch of questions came up about some of the specific projects that you shared. And I told the people that, probably the very specific project question should be best addressed to the actual researchers, not to Laurie.
I should say that I am not a PI. I'm not a researcher. I can kind of talk in general about it. Yes. I am happy to share a paper on it, but when it gets really into the technical, it's best, the individual PI.
That makes perfect sense. So Laurie, then the next question that is probably came up was that, can we get a list of some of these projects or talking points? And I obviously, the website I know has a lot of these resources, But if there's any other material that you can share that kind of makes it easy for people to kind of go through some of the points that you mentioned, that will be very helpful.
Yeah, absolutely. So I did put some of those extra links in that last slide, and I can share more too. I have a list of kind of the current things that we're working on in a couple of different spaces, and certainly happy to share that as well.
Awesome. Awesome. So, and then of course, you know, there was one question about touring the CSAIL lab once the COVID situation improves. So I know that once I was there for the Technology Review Conference, MTech, we had a really nice tour of the lab. So hopefully once things improve, those will start again.
Yeah. Unfortunately, we are all remote. The only work that's being done at CSAIL right now is the work that can't be done at home. A lot of the larger robotics, lasers, biologics, things like that we can't do at home are done there. But as far as I know, we're not going to be back until next summer. So it will be a while, but you know, you can check out our website. You can check out the Alliance's website. We are constantly posting new videos and things about the lab, and so check it out.
Sounds great. Thank you, Lori. We'll compile all the website links and other links and share with our.
Yeah, and someone just posted about labs having weekly open meetings. Not that I know of in CSAIL. Especially now with COVID. The meetings that are taking place are mainly between the students and their advisors, and those really aren't open. We do have some public talks that we do, and if you want to go to CSAIL Alliances has an events page, and I'm not really sure if the main CSAIL site has it all on there, but there is a CSAIL Alliances public events page, and you can certainly chime into some of the talks and things that are going on there. We just hosted, as part of the machine learning one, Peter Cotton, he used to be with JP Morgan, I can't remember his new company, but on micro predictions. And he has a site that you can play with all different kinds of micro predictions. So it's a really cool technology. And he just gave a talk last Tuesday, and that was a public talk. So that's available too. And we are taping most of our public talks as well. So you should be able to catch them even if they have gone past.
Excellent. And I know that some of the deep learning course lectures from MIT are one of the most popular resources on YouTube and other places. So there's some really, really good work there.
Yes, definitely. Well, that's great. So again, I'm happy to provide more information. I don't know if anyone had any kind of specific questions, but that's really an overview of a lot going on at CSAIL. And as I said, especially since we've been remote for so long, we don't really have that many new cool videos to show, but I tried to show some of the things we could and explain some of the other work that's going on, but we do have a lot of new papers. If you are inclined to read them, you can certainly share some of those. I did put some of them in the list at the end of the presentation, and I cited some others in the actual deck.
Great. And I know a lot of people were asking about the content. Lori has graciously agreed to share all the content during the presentation. So we'll post them on the Meetup page. People can access it from there. Like she mentioned, her last slide has quite a few important links in there. In addition, the CSAIL website and also the videos that they release, right, are really, really helpful. I know there's tons of content in this short time, but it has been super, super exciting.
Thank you. In true MIT fashion, right? A drink from the fire hose.
Thank you.
Any more questions, Babar, that's coming up, or good?
No, we're good.
Good. Okay, great. Thanks, Babar. Thanks, Lori, for the super exciting and engaging talk. Really enjoyed it, and so did the audience. Thanks again, everyone, for joining. We'll end the webinar now. Have a good night.
Okay, good night. Thank you, everyone.